Hello everybody. Today the video is going to be a continuation of what was, or from the last one, which was starting of chapter 9, 9.1. And the first video, if you haven't watched it, make sure you go do that. It is a short one from Friday. So it's talking about properties of radicals and how to simplify radicals. Um, how to simplify radicals into something that is a little bit easier to read so we can see what the value is of those things. Okay, so we're going to continue that today and do a couple new things. And there's this first part here is just kind of a small thing that I just wanted you to see. This is probably part that a lot of you would be able to get on your own, even if I didn't show you. But obviously, I don't want to take any chances with that. So if you're given a fraction in the assignment here that we'll have at a later time, but if you're going to have a fraction like this, the square root of 15 over 64, and you're asked to simplify that. Okay, so again, this is another property of radicals that we can use. If I have the square root of an entire fraction like that, I can rewrite it as the square root of 15 over the square root of 64. Okay, those properties of radicals tell me that I can split that apart like this and make it the square root of each part on its own. And that way I can simplify this a little bit. So the square root of 15 on top, I can't do anything with that. I can't even simplify that. If I try to do what I did Friday, I did up above, it won't work. There's nothing, the only thing that goes into 15 are 5 and 3. Neither of those are perfect squares. So the square root of 15 can't do anything with that. Square root of 64 is 8. So I can reduce this or simplify this to the square root of 15 over 8. Okay, second one here, the negative square root of 33 over 100. Same idea. I just put a negative sign in front of it just to kind of show you what that would look like. Don't let it throw you off. Just keep a negative sign in front of everything as you're doing it. So same thing. Split it up. Square root of 33 over square root of 100. I'm going to try to simplify that again, keeping my negative sign there. Square root of 33 again, that can't be simplified, just like the last one. There's nothing that goes into 33 except 1 and 33, 3 and 11. None of those are perfect squares, so there's nothing I can do with that. And then the square root of 100 is 10. So I'd have negative square root of 33 over 10. Okay, the bigger part today, kind of the part that's going to take some time to get through and explain to you guys, is rationalizing or how to rationalize the denominator. So what this means is this is a fancy way of saying is you can never leave an answer with a radical symbol in the denominator. Okay, so it's part of simplifying fractions. Okay, so back a few years ago, or 6th grade and 5th grade, whatever, in elementary school and start of middle school, when you were working with fractions a lot more, you would do things with fractions. You would get an answer, and anytime you got an answer that was a fraction, you were expected to simplify it. Even if it didn't say so in the directions, after a while it just became, I just know I have to do that. I have to make sure if I got 5/10 as my answer, I have to reduce that to 1/2. Okay, so this is another part to that. Okay, this is how I simplify fractions. And again, this might seem strange. This might seem like a totally off the wall type of thing compared to what we have been doing, but I guarantee it'll come back and it'll work with what we're doing. Okay, and in fact, we have to be able to do these things right here that we're doing here in this video. We have to be able to know how to do these things in order to solve the things that we want to solve a little bit later in this chapter, okay, which are the same types of equations, quadratic equations that we have been working with. Okay, so first example. Looks similar to what I had up above, except it's 3 over the square root of 5. So there's only the denominator has a square root symbol in it. And like I just put up here, to rationalize the denominator means I have to fix this fraction. I have to change this fraction so that the denominator does not have a radical symbol in it. Okay, it has to be a number of some sort. I can have a radical symbol in the numerator, that's fine, just not in the denominator. So remember with fractions, we can do anything that we want with as long as we do the same thing to the denominator and the numerator. Okay, just like when I reduce the fraction, like I gave the example of 5/10. I know that, we know that reduces to 1/2 because 5 divided by 5 is 1, 10 divided by 5 is 2. I did the same thing to both, right? I divided both by 5 to get it to 1/2. Okay, so as long as I do the same thing to both, whether it's division or multiplication, as long as I do the same thing to both, it is going to be the same fraction, or it's going to be equivalent. So the reason I said multiplication is because that's how we're going to rationalize the denominator, is we have to use multiplication. We have to take the square root of 5 and multiply it by something to get it to be a perfect square. Okay, so Here's the deal. Another property of radicals, okay, or really what we're going to do is use what we did in part 1. Okay, like if you think about the square root of 24, and I broke that apart into 4 times 6, and then the property of radicals tells me that I can split that apart into the square root of 4 times the square root of 6. Okay, so I'm going to kind of use that in reverse. Okay, meaning this, way down here, what can I multiply the square root of 5 by to get it to be a perfect square? Okay, well, I know I got to multiply it by the square root of something. Okay, I have to multiply by something that's a like term. Okay, so since that's a 5, the first thing that jumps in my mind is 25. So I know that 5 times 5 is 25. So I'm going to multiply this by the square root of 5. Now, since I multiplied the denominator by the square root of 5, I'm going to multiply the numerator by the square root of 5. I've got to multiply by the same thing. So when I do that, here's what this is going to look like. Excuse me, so on the numerator, I'll have 3 times the square root of 5. In the denominator, the square root of 5 times the square root of 5 is the square root of 25. What's the square root of 25? Well, the square root of 25 is 5. And now since I have a whole number in the denominator, I know I'm finished. I've rationalized the denominator. I've simplified this so that there is no radical symbol in the denominator. Okay, so again, I did that by taking whatever that denominator is and I'm going to multiply it by something to get it to be a perfect square. So let's look at another one. Whoop. 2 times the square root of 32. All right, 2 times the square root of 32. So here's what I'm doing. I'm going to do the same thing I did up above. Think about what does 32 go into? Is there a perfect square that 32 goes into? And another thing that might be helpful for this is if you want to make a list or even just go on Google and look up a list of perfect squares. Okay, and that will give you a list. If you do that, I've done it many times when I'm tutoring kids, is looked up lists for those things for them so that they can do these things more quickly. And that list, you could find a list very fast, like in seconds of, it'll tell you 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. So you can look at those perfect square numbers and work with them a lot more quickly than sitting there and thinking about them. Okay, so like for this one, for example, I have the square root of 32. So I'm going to have to multiply the square root of 32 times something to get to a perfect square. That's not super easy. Okay, for some of you, you might already have it just because you've always been just probably kind of good at mental math. Some of you might need that list. Okay, so if you got to look up a list to help yourself out, then do it. Nothing wrong with that. So 32 does go into 64. 64 is a perfect square. Okay, so if I take 32 times 2, that's 64. So I'm going to multiply, whoa, that was terrible. I'm going to multiply the numerator and the denominator by the square root of 2. Okay, so on the top, that'll give me 2 times the square root of 2, and I'm not going to use the dot anymore. I'm just going to put them next to each other. And remember, I cannot multiply those two together. I should have said this before. I cannot take 2 times the square root of 2. Those two, and the reason I can't is because those two things are not like terms. Okay, one is underneath the radical symbol and one is not. Okay, all right. So, and then on the bottom now, I know 32, or the square root of 32 times the square root of 2 is the square root of 64. And the square root of 64 is 8. Okay, now before you say, yay, I'm done, and circle this and move on, we're not done. Okay, now remember what I said about like terms. Remember I said 2 and the square root of 2 up top here, this part? I can't multiply those together because they're not like terms. Well, I can simplify this. That 2 over 8. Okay, so actually I can divide both of those by 2, and in the numerator that would be a 1 there, or in other words it would be gone, so I'd be just left with the square root of 2 on the top and a 4 in the denominator. Okay, so you look at that, it can get a little tricky, it can get a little messy, and it combines a lot of different ideas that you guys have used and done throughout the years. Okay, so there's those 2 examples. I have a couple more that I want to show you, and these are a little more difficult. So what happens when we have something like this? I have 3 over the square root of 6 plus 2. How do I rationalize that? How do I get rid of that square root of 6? Okay, and unfortunately it's not as simple as what we did up here of, oh, I just got to multiply it by, I got to multiply by the square root of 6 to get that the square root of 36, because there's 2 things down there. There's a square root of 6 and there's a plus 2. There's 2 things there, so I can't just multiply by one thing. So here's what we're going to do. We are going to use something, use an idea that we know or that we had used back in chapter, 7 maybe, okay, when we were multiplying things together. Okay, and here's what I'm going to multiply by. I'm just going to show you. I'm going to multiply by the square root of 6 minus 2. Okay, I'm going to multiply both the numerator and the denominator by the square root of 6 minus 2. Now, you might be thinking, well, obviously you see it's almost the exact same thing, right? Instead of plus 2, I put a minus 2. Why did I do that? Here's why. When I multiply this out in the denominator using the box method or the FOIL method or distributive property, that's what that is, same thing as we did before, what is that going to look like? Okay, here's what it's going to look like, and here's why this works so well to do it this way. If I multiply all this stuff out, okay, distribute all my parts. So first here, square root of 6 times the square root of 6 is the square root of 36. And remember again, as I multiply this out, what was our goal? Our goal is to get rid of all the square root symbols in the denominator. Okay, all right. So now I take the square root of 6 times the negative 2, which is negative 2 times the square root of 6. Now I'm going to take this positive 2 and multiply it by each. So positive 2 times the square root of 6 would be plus 2 times the square root of 6, and then positive 2 times the negative 2 would be negative 4. Okay, so why did I do this? Look what I have left. Okay, you might be thinking to yourself, you just made it worse because now you have more square root symbols, but I actually don't. And the reason is, if you do it this way, look at what you have here in the middle. This will always happen. If you multiply by, when you have something like this, when you have something plus something or something minus something in the denominator, if you multiply by the opposite of it, these two things in the middle are always going to cancel each other out. You see I have negative 2 times the square root of 6 plus positive 2 times the square root of 6. Those are gone. They cancel each other out. Not only that, what is the square root of 36? Square root of 36 is 6. I still have my minus 4. 6 minus 4 is 2. Okay, so by taking this and multiplying by the same thing except just changing that middle sign, when you FOIL that out, when you distribute that out, however you like to do it, box method, whatever, when you multiply that out, that pattern, okay, that's one of those special product things. That pattern is always going to make those middle two things cancel each other out, which will get rid of the stuff that we don't want or need. Okay, so let's finish this off. Now I can do this on the top as well. I can multiply this out. Okay, so remember 3 times the square root of 6. I can't multiply those together any further than that, so I'll just leave it as 3 times the square root of 6. And then 3 times negative 2 is negative 6. And I have a 2 in my denominator. And I'm done. All right, I know that probably looks really complicated. We're going to look at one more of those. Okay, and then hopefully they'll make more sense. All right, so watch this a couple times if you need to. Email me questions if you need to, obviously, that kind of stuff as you're looking at these things. Okay, so now we have 5 over the square root of 5 minus 3. So think to yourself for a second, what would you have to multiply by? Same type of idea that we did up here. Same idea we did here. What do I got to multiply by to get rid of that stuff? All right, I'm going to give you just a second to think to yourself. Even write it down on your paper if you think you know what you should have. Okay, I'm just going to start writing some parentheses in. Okay, excuse me. So what I'm going to multiply by? Remember, I'm going to multiply by the same exact thing, except I'm going to change that sign in the middle. Okay? Same thing, just change the sign in the middle. And then remember, whatever I do to the bottom, whatever I do to the denominator, got to do the same thing to the numerator. Again, when I multiply this out in the denominator, square root of 5 minus 3 times the square root of 5 plus 3, set up your box. Like you guys know, I'm kind of a distributed property guy. So when I distribute all this out, maybe I can write them over the top if I get more space. There we go. Then maybe we can see it a little easier. So first thing I'm going to do, use my little laser pointer thing, is I'm going to take the square root of 5 times the square root of 5 and the square root of 5 times 3. All right, so square root of 5 times the square root of 5 is the square root of 25. Square root of 5 times 3 is 3 times the square root of 5, because I can't multiply those together because they're not like terms. Okay, now I'm going to take this negative 3, looking at the little laser pointer thing, negative 3 times the square root of 5, and negative 3 times positive 3. So that'll give me minus 3 times the square root of 5. And negative 3 times positive 3 is negative 9. Okay. Now, again, just like the first one, what happened? All right, if you multiply this out correctly, this should happen again, where I have two things here. I have a positive 3 square roots of 5, and I have a negative 3 square roots of 5 that will cancel each other out, which gets rid of all of those radical symbols that we don't want. The square root of 25 is 5 minus 9. 5 minus 9 is negative 4. Okay, so again, if you do that right, you multiply it out correctly, you should come out to have just a number left over. And now, Let me zoom out a little bit. Now I can take my numerator, multiply that together, distribute. So 5 times the square root of 5. 5 times 3 is 15 over, now I know a lot of you are thinking over -4. Okay, which is fine, but remember, if that one part is negative, I could also just put it in front, but I already wrote it there, so I'll just leave it. And there we have rationalized our denominator. Okay, so again, seems weird, this seems different. It'll probably be a little bit of a struggle when you start the assignment and start to work through that. That's okay. Ask questions, email me. I'll probably set up another meeting or a Zoom or whatever. We can use Zoom now, so we can do that, and you guys can jump on and ask some questions if you have to, okay, or if you want to or need to. All right, so watch again if you need to, and again, this stuff will be useful for us as we start solving these equations again here in Chapter 9 as we keep going.